Morning, my name is Andy Young and I'm one of the lecturers down at Unitec in Auckland, and we teach, well, one of the courses that we provide our students is within the automotive field, and I produce on a regular basis videos which cover aspects of the course, what our students are going to be learning about, and use those within an e-learning environment, which means that the students, we put them online and the students can watch them again and again, which is, in my opinion, far better. We get students from all over the world. English may not be their first language, and it means that they can stop the video, check out a word, do some research, and then carry on again. Far better environment than going through it only in the workshop. Of course, we do a lot of stuff in the workshop as well, but these videos are additional. Now, we're actually currently working on a Yamaha Viking side-by-side ATV. It's a 2013 model, and this is the third video in a series. The vehicle came in originally with a suspected blown head gasket, and the first video covered the removal of the engine from the vehicle. Now, like I said previously, it's not necessary on that particular vehicle to remove the engine just to do the head gasket, but there were a range of other faults, which meant that taking the engine out was going to be a real benefit to getting those other faults fixed. And also it really helps with the filming side of things for you guys. You can see a lot more, we can get in there, we can get some proper light on the whole thing. Working on engines on the bench is far better than working on them in the vehicle. You tend to rush through it on the vehicle. There are a number of other issues that need to be addressed as well, which will be covered in subsequent videos. We've got brakes overhaul to do, other stuff like that. So this being the third video, we've already pulled the engine out of the vehicle. We've already stripped. Second video covers stripping the cylinder head and the barrel off the engine for inspection. This is a single cylinder 4-stroke engine of around about the 700cc mark, I believe. Now, this is the barrel. With motorcycle engines, the barrels are separate to the crankcase. On most car engines, you have a block. Now, the block is the crankcase and the barrels all in one big lump. So on motorcycles, we have a lot more options. I much prefer working on motorcycles, but anyway, that's the way it is. And this engine, because of the blown head gasket, this engine anyway, for whatever reason, may not be the head gasket that caused the original overheating. I don't think it was. I think it was a faulty thermostat. Has been used extensively for a long period of time with this overheating problem. Now, the user of the vehicle has told me that they only used the vehicle for short distances, and every time they used it, they let it cool down, topped it back up with water and that kind of stuff. Still a bad situation. Sure, if it's managed correctly, you can do it for a short time, but I think this has been going on for quite some time. I'm not exactly sure on the time frame, but this engine's been going from cold, engine off overnight, to excessively hot, to cold to excessively hot. Now, all the customer sees is the temperature gauge on the vehicle. I think these vehicles, all they have is a cold engine warning light, so probably blue, and an overheated engine warning light. They don't see the range, they just see these lights coming on if there's a problem, or when the engine's cold and when there's a problem. When you've got a blown head gasket, we're getting combustion gases being pumped through essentially into the coolant system. Within the combustion chamber, we're getting pressures of up to maybe 250 psi, just through the compression ratio itself, maybe 200, 180 probably on one of these, 10 to 1. But in addition, we're getting the explosion. Now, when the explosion occurs, of course, we're getting massively high pressures. I have no idea what they are, but they're a lot more than 180 psi. That pressure leaks through from the cylinder into the water jacket, and it's pressurizing the whole of the coolant system. This is putting exhaust fume gases into the cooling system and creating gas pockets within the coolant. And whenever one of those gas pockets trundles around the cooling system and goes past the engine temperature sensor, a gas doesn't conduct the heat, doesn't transfer the heat anywhere near as well as a liquid. So the temperature sensor actually, usually, will read cooler. For that moment in time, it will read cooler. So we're going to be getting, the driver's getting an inaccurate reading of engine temperature. They're just really seeing an average of the whole thing. What's really happening inside the engine is we're getting periods of time when the head and the barrel are not being cooled at all. There's no coolant liquid in that area. So we're getting hot spots. And of course, as you know, through thermal expansion, hot spots, the temperature causes the metal in that area to expand a lot more than the metal that's nearby that's maybe got some coolant against it and is being cooled. This can cause distortion within the components, and this distortion from an engineering perspective is extremely bad. You know, when we make a cylinder round, it's made round for a reason. You know, we make a piston. Manufacturers put a piston in there and they make it round. They spend a long time making this piston really, really round and nice and proper. And through heat distortion, things end up not being what they used to be, as in the shape. A very common problem with heat distortion is the mating surface here, where the cylinder head goes. You've no doubt heard of a warped cylinder head. Now, of course, if we had multiple numbers of cylinders, we had a head with 4 cylinders, you know, four heads built into it, like an inline 4, or a straight 6, with an aluminium head. Aluminium heads are far more prone to warping than cast iron. Then, of course, that warpage will be exaggerated along the length. With a single cylinder engine, yes, you can still get a warped head, but it's usually not affected as badly, because it's essentially a lot smaller. We also have the same mating surface on the cylinder. Here, look, this is where the head gasket goes. And you get the same problem, of course, on an engine block for a car. So if it overheats, it could distort. Now, that warpage is going to cause a change in clamping pressure between the head and the block, or the barrel in this case. So in some areas, the head gasket is going to be over squashed, over clamped. In some areas it's going to be about right, and in other areas it's not going to have sufficient clamping force, which means again the head gasket at some point in time is probably going to fail at the point where there's insufficient clamping force, or maybe where there's too much, depending on the situation. Every time the engine warms up, the head and the barrel, or the block, expand. And if they're aluminium, they expand a lot more than the head bolt. So that head gasket actually gets squashed a bit more when the engine's at operating temperature, and then gets squashed a little bit less as the engine cools down. If we've got irregularities around that surface area, then of course it's going to cause more squashing of the gasket in certain places and less squashing of the gasket in other places. And all these irregularities can cause problems. And this is why you've got to check to make sure that these surfaces are flat, within tolerance, within manufacturer's spec, and we use a workshop manual for that. Because if they're not, then you've got to send it away and get it machined. You've got to get the head machined, and if the block was badly distorted, or in this case the barrel, then we'd have to get the barrel machined as well. Now, if we take away material off the head and off the barrel, where the head gasket goes, then essentially the whole thing is a little bit lower, and the piston, in effect, is going a little bit further up. And we're going to get a higher compression ratio. Now, of course, there are limits to the amount of material we can take off. You could compensate that by fitting a thicker head gasket if it was available to bring the compression ratio back to what it should be. There's lots of different ways of doing it, but if you don't get the machine surfaces remachined flat, then the head gasket repair that you're doing, if they've got distorted, the head gasket repair that you're doing, you just chuck a new gasket in, bolt it back up, job's a good one, off you go, mate. Then there's a problem. It's probably going to fail again sometime in the near future. It might last a year, it might last 18 months, and then you're back to the same problem again. This is why, usually, the original head gasket that was put in the vehicle on the engine when it was born maybe lasts 10, 15, 20 years. And then the engine for some reason overheats, it gets a new head gasket put in, and it lasts a year, and then it has to be done again because the garage that did the work didn't check the machine surfaces for flatness, and as a result they just chucked a head gasket in, and of course because of these irregularities it's failed. They have only done half the job. Garages often don't like to send things away to get machined because of the turnaround time. They've got a car in the workshops in bits and they're waiting for somebody else to do their bit, get the parts back before they can carry on. They want the quickest possible turnaround, get the vehicle out, yes it's fixed, it'll last for the warranty period, everybody's happy, until it fails again and the customer's a bit confused, well I only had it done 18 months ago. Okay, so rather than babbling on for hours and hours, hopefully that was educational for you, we're going to work our way through and inspect these various engine components, not just for wear. It's only done 9,000 Ks, it's not a particularly old vehicle, I'm not expecting to find lots of wear, but it has been overheated many times. So I want to make sure that the components here haven't been distorted because of that overheating. So we're going to go through, I've got the Yamaha manual, I'm going to go through each particular measurement step by step, and I'm going to present each one separately because I think for my students they're going to be presented as separate videos, so there'll be a lot of stop-starting going on. And if any of these components are outside spec, then they're going to have to be replaced. This is essentially quite a new vehicle, only 18 months old, and it operates a long way from civilization. So, well, it's on an island just off Auckland, but it's a real hassle to get it back to the mainland to get it repaired. So I want to make sure that this repair is 100%. Everything's been checked, whatever needs to be replaced is going to get replaced, so that when it's delivered back to the customer, maybe in a week's time or whenever it is, it won't go until it's fixed. It's handed over with everything fixed. I don't want him to incur any additional expense having to send the vehicle back because something else has failed that could be related to an overheating problem. So the first inspection we're going to do, we've got a couple of inspections to do on the barrel, we'll get that out of the way first because that's the quickest one, is to get what we call a straight edge, and we're going to measure across the top of that barrel using a straight edge rule and feeler gauges to see how much of a distortion there is. In addition to that, we're also going to measure the bore in a number of different positions. We're going to check it in the vertical, as I'm holding it now, and in the horizontal in 3 positions down its length. So we should end up with 6 measurements and they should all be within spec. Once that's done, we'll move on and we'll tackle the head. Now there's a lot more work to do on the head. I've got to pull the valves out, we've got to check the valve guides. Whilst all that's been done, I'm going to be fitting new valve oil stem seals. Valve oil stem seals. Inherently, the rubber of them, the sealing part, goes hard when an engine's overheated, and that can cause the engine to burn oil, especially on overrun when you're going down a hill. We don't want this engine to be burning oil. It's a relatively new engine. The customer doesn't want to be topping the oil up every 5 minutes, and of course it's bad for the environment as well. So whilst the valves are out, we're going to measure the valve stems, and whilst we're measuring the valve guides to make sure there's no excessive wear on those either, we'll flick out the old valve stem oil seals and we'll put some new ones in. I've already got those ordered. Okay, so we're going to check. The first check we're going to do on this cylinder is we're going to check for warpage on the top of the cylinder where the head gasket goes. Now, the specification for this, according to the Yamaha manual, well, in actual fact, the Yamaha manual doesn't give us a specification for the warpage on the top of the barrel. They do give us the warpage for the head, which is 0.03 millimeters. Now, your common garden feeler gauge set, like that one there, doesn't go anywhere near small enough. I have here a genuine Yamaha feeler gauge set, very small, great for doing clearances and so on valves and things like that. And it only has a limited number of feelers, I suppose. This one is the smallest, it's 0.02. So if this doesn't go through when we're testing it, and you'll see how to test it in a second, If this doesn't go through, then we know we're definitely within spec. If it does, the next size up is 0.05 on this feeler gauge set, millimeters. Then if the 5 doesn't go through, but this does, then we're going to be somewhere between those 2 points. And, well, it's going to be close because this is 0.02. If this was to go through really easily, then I would give it a fail. If it was a very tight fit to get it through, then I would still pass it. So it's all about the feel as well. And you've got to really use the tools that you've got. And I think to try and find a feeler gauge of... We have one. Look at that. I've just found it. Okay. So we've got exactly what we need. It was stuck to the 0.02. These things are like... It's just foil. It's so thin. So we will use the 0.03. And if it doesn't go through, it's a pass. And if it does go through, it's a fail. Now, if it is a fail, what that means is we're going to have to send the barrel away, or the head, whichever one fails, or if they both fail, to get machined. And they'll stick it in the milling machine and they'll just flat it off for us. Okay, so we've got what we need, a 0, you can see that? Yeah, you can, look at the camera, it's fantastic. 0.03 millimeters. Any bigger gap than that, it's a fail. Any smaller than that, it's a pass. Okay, so we get our straight edge. Now this one is for automotive. It's really long. It's designed for doing big long cylinder heads. You don't need one anywhere near as long as this to do a single cylinder one, but it does the job. This surface along here is machined, and ideally it's supposed to be dead flat. This is our point of reference. And what we do is we place that across the cylinder head, across the cylinder barrel, like this. We get our feeler gauge, and without putting any pressure on it, because we don't want to distort it, we just go along and we see if that will fit under any of the points of contact onto that barrel. Now, if it does, if it goes all the way through, so that's a pass, we're all good there. And we'll do the other diagonal now. Now, I haven't done this previous, so I have no idea what the results are going to be. There we go. So that's a pass, and now we need to do it across here. Let's do it across there, look like that, by where the holes are. Let's move it across, it balances a bit easier. There we go. Yeah, that's pretty close. Let's give that another go. Now remember, it was the exhaust side, which is this end, where the head gasket failed on that particular bolt. So this is the area that gets the hottest. So we'd expect to see the most distortion there. Nope, that's cool. And if we do, turn the head round, if we do across here, great job. Okay, so that's a pass, and I'm very happy with that. Okay, so with that quick test then, so I've got to hold it quite a long way up this time, we've now measured to make sure that that is still a machined, flat, within specification surface. The next test is to check the barrel itself, the bore, should I say, in here, to make sure that this hasn't become distorted as well. That should be round. That was what it was made when it was new, and it should still be round. So we're going to be measuring across the bore, at the widest point obviously, in 3 positions going down in that plane, and again 3 positions going down in that plane. And we're going to compare the results, because we could end up with a tapered bore, we could end up with a barrel-shaped bore. There are specifications, which I'll give you very shortly, about what's permissible, what isn't permissible. If it's out of spec, if that bore's got distorted or excessively worn, doesn't look worn, then again it will be a fail, and we'd need to either send it away and get it rebored, or depending on if it's a coated bore, and it could be, it could well be, it may be a new barrel. Okay, so to measure the cylinder bore, there's a number of different ways of doing it, and this is quite an accurate way. This is what we use at Unitech. This is a bore measuring device. Essentially, it's got a DTI fixed at one end, and at the other end, we can choose whatever length rod to go in here. Now, you can see this on the screen or not, but as that rod is compressed, it's gonna, there you go, it's gonna move the DTI so we can take a reading. So, according to the specifications, this bore should be 102 millimeters in diameter. The specification is 102 to 102.010 millimeters. It's quite a fine tolerance. So what we need to do is, in the kit, we have, I can hold this up without it all falling down, we have a range of different rods. And if you can see those there, look, we've got the different numbers on. So we've got down here, that one there, for example, is a 95, I think a 90, yep, 90 and so on. So our bore is 102. So I've taken out the 100 millimeter rod and fitted it to the tool. But I've also added, and if you can see over here, there's some little tiny washers. That one there, look, there's one, okay. And I'll show you how to fit that shortly. That's a 3 millimeter. And of course, there are some smaller ones. That's a 1/2 mil there, look. Okay, obviously one of them is missing. So what you do to fit those is you can undo the end here, look. That comes off. We can slide that down, get rid of that. And then if I just pull those, oh, hang on, do those to the camera look for you. If I now just take that out, put the tool down, you'll see we have the 100 millimeter rod. Is it labeled? No. Okay, so came out of the box. 100 millimeter rod. It's got a little tiny ball bearing on the end, so there's reduced friction when we're testing it. And we've got a 2 millimeter spacer. So if we add the spacer to the back of the rod there, look, like that, then essentially we're going to have it set up for a bore of 102 mil. Now that then goes on there like that, and then we put the collar over the top and tighten it up. So in theory, when those are not pushed in, so it's free, it's 102 mil. Now obviously we've got to measure that, and we could use, because I always like to double check, we could use a micrometer to measure that, to make sure that we're absolutely bang on, because the measurement we need to take, you know, that 102 millimeters to 102.01 millimeters is a really accurate measurement. So if we don't set the tool up properly at the start, then there's a very good chance we're going to get the wrong measurement when we start measuring the bore. And then we're going to think, well, hey, it's either in spec or outside spec based on those results. But those results are going to be flawed, which means what's the point in doing it? Now, in all honesty, the majority of garages would not do this. This is more of an engine reconditioning kind of thing. Most garages whip the head off, put the head gasket in, have a quick look around, clean it up, chuck a new head gasket in, bolt it up, send it out, job done. What we're doing is slightly more involved. It's not often that I even get to do this kind of stuff. Sure, I teach it, but you know, I only cover this once or twice a year. And it's only in extreme cases like this, and of course when we're doing a video, that I want to show you the proper way of doing stuff. Now, it's unlikely that you're going to have the opportunity to get your hands on one of these. They do exist, you can buy them, of course you can, but they're going to be reasonably expensive because they're a specialist piece of equipment. Okay, so I'm now going to just get a micrometer and double check that we've got exactly 102 millimeters across there. Okay, terrible camera work. Right, what I've done is I've set it up so that the distance on this tool is 102 millimeters, which is the specification for the barrel. Now, when this tool is into the bore, I've set it up so that, and I will readjust it, but it should go to 0. That's exactly 102 millimeters. Now, each increment on this DTI relates to a distance of 0.01 millimeters. Our specification for this bore is 102 millimeters, which is the original machining. Well, 102 to 102.01. That's the tolerance for the machining in the factory. Now, that means that we can only deviate by one of those very tiny increments on the gauge. That's what it should be at original spec. Now, the bore can be worn to 102.08, which means we can actually afford to go 8 of those very small increments. So from 0 to 8. Anything more than that and the bore is worn out. In addition, we have a limit to taper and out of round. Now that limit is 0.05. So we need to take 6 measurements, and if we get a deviation in the readings on either the X or the Y planes of more than 0.05 mil, then again this barrel would be a fail and it would need to be either rebored or replaced. So I'm going to set the tool up, I'm going to gather the readings, and then we'll go from there, okay? Okay, so I've just chopped my head off, but that doesn't matter. Right, main important thing is you can see the tool. Now, we pop the tool into the bore. Tell you what, let's do it the right way up. A bit easier for you. Okay, a bit easier to understand. Now, I'm going to put the tool in and I'm going to run it right down to the bottom of the bore. So we're right down near the bottom and we're doing across the cylinder. So from side to side of the engine initially. And it's important that the tool's in the vertical position. Now, if you move the tool from left to right, you want to take the reading of the shortest possible distance. That tells you that the tool is vertical. So if we just gently move that from side to side, yep, we're bang on 0, which tells me that that bore right down the bottom, which is what I would expect, where the piston rings don't run, they don't make any contact, they don't go far enough down the bore for that, we've got an exact reading of 102. So I'll just grab a pen and we'll write that down. Okay. So 102 exact. Moving to about halfway up the bore. Again, we want to take the shortest possible reading. That tells us we're accurate. And again, we've got no wear whatsoever. So that's 102. And then we come up the bore, but we don't want to go beyond where the rings run. And again, very good actually, 102 exact. Now we're going to rotate the tool, or in fact I'll rotate the bore around so it doesn't affect where the camera is. Okay, and now we're doing front to rear plane. And again, we'll start down the bottom. Okay, well we have got some distortion there, and you can see that we're 2 increments off the 0. So that's going to be 102.02 millimeters. Okay, so 102.02. And that's right down the bottom, that's not where the rings touch. So that definitely is some warpage relating to, no doubt, that overheating problem. But at that point in time, on this particular reading, we are still in spec. So we'll bring the tool up now to about midway up the bore, and we'll take another reading. And again, I'm getting about half, so on that one we've got 102.015, and then bring it up to the top, but just before where the rings stop touching. And it's actually looking at that reading, we're actually 0.01 narrower at that point. So at that point there, we've got 101.99. Yeah. So there is some slight distortion of that barrel due to heat. And of course it has to be down to heat, because there is no possibility that it could have worn smaller. Things only wear bigger, okay, in this universe. So there you go, we have got some slight distortion. Very, very accurate tool. I think NASA used more accurate stuff than this, but hey, this is definitely accurate enough for us. No significant wear on the bore, and I wouldn't expect there to be, really, given the age of the vehicle. However, we did see the engine oil that came out was badly contaminated with water, which meant it had less lubrication properties. So, you know, the bore could have been scored, but looking at it, there's no visible scoring, and as a result, this has proved there's no wear. However, with the readings that we've got, we have seen that there is some distortion due to the heat. And looking at the figures, we are still well within both the taper and the out of round limits. So that's a really good verdict. This barrel is overall a pass. It's passed its visual inspection, checking for scores and so on inside the bore. It's passed the surface where the head gasket goes. We know that's within specification. It's nice and flat, doesn't need to be machined. And now we've measured the bore. We measured the bore in 6 different positions. We've checked it for wear, we've checked it for taper, and we've checked it for out of round. Now, just to run through those specifications for you again, because you need this kind of stuff to be able to, you know, there's no point in measuring things if you haven't got the specs. The cylinder bore, when it was originally manufactured, the specification should be between 102 millimeters, that's 102 millimeters, to 102.01 millimeters. That's the tolerance that Yamaha machined these bores to. The wear limit for the bore can be up to 102.08 millimeters. The taper and the out of round specs are both the same. It must not exceed 0.05 millimeters in either taper, that's the bore tapering down, so we've got a difference of 0.05 mil distance from across the top of the bore, maybe down to the bottom of the bore, or vice versa, you know, however it's worn. And of course, out of round, well, you understand what out of round is, you know, it's not round. Again, same spec, 0.05 millimeters. So this is checked out. It's within all of those specs, well within actually all of those specifications. The only thing that I have picked up on with the tool is that running across the forwards to back on the cylinder, that's this way. The cylinder has very, very slightly been pulled in due to heat distortion. Okay, I would expect, therefore, the measurement on the other axis to have been slightly greater. It wasn't, it was bang on actually. But there is some slight heat distortion. Don't think it's going to cause any major problems. We're only looking at 0.01 of a millimeter off spec. Slightly smaller. Is the piston going to bind on the bore? I don't think so. I think that distortion was far enough at the top not to cause any major concerns. There is there's no picking up of the piston, there's no rubbing on the bore, so I think we're going to be okay. So I will finish cleaning this up. It needs I've already cleaned where the head gasket goes. It needs the area where the base gasket goes to be fully cleaned, all the old gasket to be removed, and then that's ready for for the rebuild. Okay, I'm going to grab a coffee. That's enough for this morning. Talking to myself, crazy. I will leave you to it. Thank you very much for watching. My name is Andy Young and I'm one of the lecturers down at Unitec in Auckland, and I teach automotive. And I hope you found this video helpful. Cheers.